Hi everybody, welcome to another video in Pre-Calculus, section 5.3. Computing the values of trigonometric function of acute angles. So once again, we still only restrict the angles to acute angles, meaning between 0 and 90 degrees. Right, now let's work on two special cases, one of which 45 degrees and the others 45, 30 and 60 degrees. Right, 45 degrees. Suppose we have a right triangle, one of them is 45 degrees, one acute angle is 45, and since the angles add up to 180 degrees, this is 45, the other one, subtract from 180, 180 subtract 90, subtract 45, this angle should also be 45 degrees. Right. Now, assume that this is a triangle. We have 45, 45, 90 degrees, using Pythagorean theorem to find the length of B and C. Now, if we have the length of A is 1, B, because this angle are the same, opposite to the same angles on length are sides with equal length. So 45 degrees, both of them opposite from 45 degrees, so the length should be the same. Both of them are 1 and 1, so it's easy. Then the Pythagorean theorem, A squared plus B squared equal to C squared. A is 1, B is also 1. That gives us C squared. So C squared is 2, or C is equal to square root of 2. Right? Yeah. So C will be square root of 2. And this triangle we have, let's say with respect to this angle here, this is opposite, this is adjacent, and this is hypotenuse. With that, we can write the sixth trigonometric function for 45 degrees. 45 degrees is pi over 4 radians. Right, so sine of 45 degrees equal to opposite over hypotenuse. Because if we don't want to write square root at the bottom, we always can multiply square root 2 top and bottom. Square of 2 times square root of 2 is 2 at the bottom. The top, square root of 2. If that is sine, cosecant is reciprocal to that. Will be square root of 2 over 1. Because reciprocal to this. And now cosine of 45 degrees. Cosine is adjacent over hypotenuse. And similar to the previous problem, I multiply square root of 2 top and bottom. So that we have 2 at the bottom. That gives us secant square of 2 over 2. And secant is the reciprocal of cosine. So we just flipped square root of 2 over 1. And we have square root of 2. And then tangent. Opposite over adjacent, which is 1. And cotangent is reciprocal of 1, which is also 1. Right, so we have special values, trigonometric function values for 45 degrees. That's what we have. Now, another special case is where we have 30 degrees and 60 degrees. So in the triangle of 30, 60, and 90. So what's so special about this? Well, I should put that triangle over here. Right, let's do that again. So we have, actually, I have this set of 45, 45, and 90 degree triangle, and this is 30, 60, and 90. Okay, so I will draw this again. It's easy, we know that is 30 degrees. Right. So we have 30 degrees here and 60 degrees here. Of course, here is 90. Right. What's so special about that? Well, now if we flip that to the other side, it's easy. Let's see, about 2 centimeters. Right, now I just flipped that triangle to the other side, so mirror image. If that is 30, then this is also 30, and this is also 60 degrees. It's just a mirror image of each other, and of course that also 90 degrees. So what we have here is an equilateral triangle, because 60, 60, and that also 60. So equilateral triangle. So in the case of we have 60, 30, and 90 degrees right triangle, we can say that a special case, this is half equilateral triangle. Now, if we let A equal to 1, B we don't know, but because if this is 1, this is also 1, and the total, that will be 2, and the hypotenuse, because being in the equilateral triangle, this will be 2. Right? So this triangle, A is 1, and C is 2, and A is, let's say, okay, worry about the angle later. Just solve for B first. A square plus B square is equal to C square. A square, 1 square. C square is 2 square. So B square, 4 minus 1 is 3. Once again, in a right triangle, or in any geometric shape, the measure cannot be negative. So we just say square root of 3. So B is square root of 3. Right. Now with that we can write sine of 30 degrees, I mean on a trig function for 30 degrees and 60 degrees. Since there are 2 of them, let's just do both. First, sine of 30 degrees. Now sine of 30 degrees, with respect to 30 degrees, this angle, this is opposite, and this is adjacent. With respect to that angle, hypotenuse is still C, so opposite over hypotenuse. So we have that is sine, so reciprocal of that, cosecant, is reciprocal 2 over 1 or 2. Now cosine of 30 degrees. Now cosine of 30 degrees, with respect to 30 degrees, adjacent over hypotenuse. Secant is reciprocal of cosine. if we don't want square root of 3 at the bottom, just multiply square root of 3 top and bottom. That gives us 2 square root of 3 over 3. That is cosine, and then tangent. Opposite over adjacent. If we don't want that square root at the bottom, multiply square root top and bottom. So give us square root of 3 over 3. So that is tangent. Reciprocal tangent is cotangent. I'm going to flip it, square root of 3 over 1. That's square root of 3. That's what we have for 30 degrees. Now the nice thing about this, what we have in the previous section, is that 30 degrees and 60 degrees add up to 90 degrees. So those are complementary angles. So we can say sine of 30 degrees is cosine of 60 degrees, and so on. But we notice that, but we still do it. So sine of 60 degrees. Now with respect to this angle, this is opposite to that angle, and this is adjacent to it. So sine of 60 degrees opposite over hypotenuse. It will see cosine and sine being co-function of each other, 30 and 60 complementary angle. So we can go from sine 60 to cosine 30. They should be equal. And then reciprocal of sine is cosecant. Once again, rationalize the denominator. Right, next, cosine 60 degrees. With respect to 60 degrees, that this is adjacent, which is 1 over 2. Of course, that will be the same as sine of 30 degrees. Reciprocal and finally tangent of 60 degrees, opposite over adjacent, and cotangent reciprocal to that is 1 over square root of 3, and rationalize the denominator. Right, so that's what we have. So those are the special values of this trigonometric function values. We have 30, 45, and 60. That's what we have. Right, of course we can put in the table like this. So first, in degrees, pi over 6, in radian, pi over 6, pi over 4, and pi over 3. Equivalent in degrees, we have 30 and 45 and 60. Those are the special values that we know the values of. Okay. Now, if you took my trigonometry class, then you know this trick already. It's called the hand trick, either the left hand or the right hand. But let's see, this is the hand. So we have the special values on the hand. 0 degree, 30, 45, 60, and 90. Equivalently in radian, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Right, so those are the special values corresponding to the hand. And then what we define is the sine of an angle is equal to the numbers of fingers on the right divided by 2, square root of the number of let's say on the right, finger on the right. Number of right fingers. And then cosine equal to the square root of the number of fingers on the left. Just write it down first and then we'll explain more of that. And then tangent. Tangent being sine over cosine, so number of right fingers over the number of right. Right, now what we do is, let's say if we have 30 degrees, if we do that on the hand, we just curve that finger down, and that's what we have. So ignore that fingers. In that case, size is the number of the right fingers on the right of that. So we have 1 fingers on the right divided by 2. So sine of 30 degrees is 1/2. Square root of 1 over 2 is 1/2. And then cosine is the number of fingers on the left of that divided by 2. For example, 45 degrees, cosine 45 degrees, there are 2 fingers on the left. Square root of that divided by 2. And because of that, as you see, when we go from 0, 30, 45, 60, 90, we have square root of 0, square root of 1, square root of 2, square root of 3, and then square root of 4 on that direction. So sine is under increasing function. Of course, we talk about that later. Right, so that's what we have here, that trick. Right. I'm just going to keep that somewhere. Right, now 45 degrees means sine of 30, 1/2. Just brought a little. Yeah, I'm not an arc major. Anyway, 0, 30, 45, 60, and 90. Equivalently, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Right, so 30 degrees, so 1 finger on the right, square root of that divided by 2, so we have 1/2. Cosine, number of fingers on the left, there are 3 fingers on the left of 30, square root of that divided by 2. And tangent, we just divide these 2. Sine, tangent is equal to sine over cosine. So we have 1/2 divided square of 3 over 2, which multiplied reciprocal. We have 1 over square root of 3. Or if we use the hand trick, the number of fingers on the right, square root of 1 divided by square root of the number of fingers on the left, square 1 over square root of 3, which is that. And then the reciprocal will be easy. Reciprocal of sine, reciprocal of cosine is secant. Multiply square root of 3 top and bottom, and reciprocal of tangent be square root of 3. Right, next 45 degrees. There's 2 fingers on the right, so we have square root of 2, square root of that, divided by 2. And also for 45 degrees, there are 2 fingers on the left, so square root of 2 over 2. Since these two are the same, the ratio will be 1. Cosecant reciprocal, and multiply square of 2 on top and bottom, we just have square root of 2. Same thing here. And then 1 over 1 still 1. And then 60, well, 60 and 30 are complementary angles. So 1/2 you can just say but let's say 60 degrees. So 3 fingers on the right, square root of 3 over 2 is sine. Cosine is square root of 1 over 2. And then divide these two, we have square root of 3 and 1 over square root of 3. And then we just flip them. Yeah. So there's a lot of ways we can do this. Of course, we can use that hand trick. I put that next to the hexagon. Or we just do it the long way and draw the triangle and try to find it. Right. But apply the right hand. I mean, whatever, left hand or right hand with the hand trick. Find the exact values of each of the following expression. Sine of 60 degrees. 60 degrees. And sine, the number of fingers on the right, take square root and divide by 2. And cosine of 45 degrees, number of fingers on the left, take the square root, divide by 2. Multiply this, we have square root of 6 over 4. Simple enough. Next, tangent of pi over 6. Tangent of pi over 6. Tangent is square root of fingers on the right, square 1 over square root of 3. Just 1 over square root of 3. Cosine 45 degrees or pi over 4. Cosine is fingers, number of fingers on the left. Take square root, divide by 2. So that's what we have. Of course, we can do the common denominator. Is 2 square root of 3. So I will multiply 2 here. And then multiply square root of 3. So I have 2 square root of 3 at the bottom. Common denominator on the top, I have 2 plus square root of 6. That's what we have. Next, tangent of pi over 4. Tangent of pi over 4. Tangent is square root of number of fingers on the right divided by square root of the fingers number on the left. So square of 2 over square root of 2. So this is 1 square. And sine of pi over 6. Sine pi over 6. Number of fingers on the right is 1 square root of 1 over 2. And then there's a square. So 1 plus 1/4. 1 1/4 is 5/4. Right, that's simple enough. Now if we use a calculator, then make sure that it has to be in the right mode. Heat mode, this is in radian. So if we want degrees, make sure it's in degrees. And we'll just say cosine of 53 degrees. That is about 0.6018. Now, cosecant of 68 degrees. The calculator typically don't have the cosecant. So in that case, we have to write this as the reciprocal of sine. So we have 1 divided by sine of 68 degrees. We have 1.0785. Right? So that is in the degree mode. Now if we want to use in radian mode, we have to select the radian. And then tangent of 5 pi. That gives us 3.732. So whenever we use a calculator, make sure that it is in the right mode. Right. Now let's go to some application problems. Right. A rain gutter is to be constructed by a piece of aluminum sheet and 18 inches wide. So we have a piece like this, and we form the sign up. So it will have a rain gutter. The cross section is could be like this, could be a trapezoid, or could be very flat. But that will give us a rain gutter, right? That is the cross section to the rain gutter. Right. Now, so we have 5 and 5, and then we try to fold it up. This is the cross section. Now we're trying to find the area of the opening, which is the cross section area, as a function of theta. So this is theta. Right. Now how do we find the area of the cross section? By the way, let's just draw this without all the other details. Right, have that much. Okay. Right, I see that is cross section area. Right, we have here's the length 5, here's 5 inches, right? And then the angle that we form up is theta, is the outside angle. So we also have angle theta here. Right, now try to find the area of that trapezoid. Right, first we can cut in that, and that will be h. Let's say this is the height of a trapezoid. So to find the area, first we can say the area is equal to what? first the area of the rectangle here, area's length times width, 5h plus. Now we need the area of the two triangle here, right? So if we put those two together, that will form a triangle, but let's just use the triangle. So the area of this triangle, let's say this is h, and let this be b, and this triangle is 1/2 base times height, right? This area for that triangle is 1/2 base times height, right? Now, what is the base? What is the height? So in that case, the area of the whole gutter is 2 times the area of the triangle, which is 1/2 base times height. Right? There are 2 triangles, and so that's what we have. So we will have 5h plus 1/2 and 2 cancel out bh. So we just need to find what is h and what is b. Now we draw another triangle, bigger triangle. This is h, this is b. By the way, if this is angle theta, this is also the angle theta, or this is also angle theta here. And this is 5 because we fold up. That will be 5. Now, with this, we can say, with this triangle, with respect to angle theta, sine of theta is opposite over hypotenuse. So we can say hypotenuse is 5, sorry. Opposite is h over hypotenuse. So cross multiplying here, h is equal to 5 h is equal to 5 sine theta. And then when we write cosine is adjacent over hypotenuse. And cross multiply cosine. That's what we have. And with this information, we can put it back in here in terms of h and b. So the area in terms of theta is 5 times h times sine of theta, which is h, plus b times h, 5 cosine is for b, and 5 sine for h. Give us 25 sine of theta plus 25 sine theta cosine theta. Right. So this is the area in terms of theta. The unit will be inches square. Right. So that is the function. Now compute the area of the cross section, the opening, when theta is equal to 30, 45, and 60. By the way, once again, this is in degree mode. Make sure it is in degree mode. Alright, it is in degree mode. I will enter the function 25 sine of, let's use x instead of theta, plus 25 sine of x cosine of x. Right. And then we evaluate when x equal to 30. By the way, we enter this into y1, right? Second mode quick. If you have this calculator, we can hit variables, y variable, function, y1. So we have y1 evaluate at 30. So when theta equal to 30 degrees, the area is equal to 23.325. Again, it is inches square. Theta equal to 45 degrees. Once again, variable, y variable, function, y1. Or we can just hit alpha, trace. Oh, that's y1. Yeah, alpha and trace. If you calculate when you hit alpha and trace, that show up y1, then we can just use that. Right. Now that's 45 degrees. And we have 30.178 inches square. When theta equal to 60 degrees, area equal to or just highlight it and change to 60. 32.476 inches square. Right, so that's simple enough, right? Now, use the calculator to find the maximum area possible. So in that case, we have to be able to graph the function and to determine what will be the maximum area. Right. So we have the function already. We hit the graph. However, we won't be able to see this yet. Right. Since theta we can form, if 0 degree we have flat. For 90 degree, that's where we have this. Of course, if it's more than 90 degrees, we will have a very small area. This is not going to be maximum area. And so we just go from 0 to 90 degree. So I hit Windows. Let's go from 0 to 90 degrees. The X scale, again, hit Windows, go from 0 to 90 degrees. The scale, let's say, 1 tick is 10. Right. The Y minimum, it's not going to be negative 10, right? The area cannot be negative. So we could go from 0, but usually I would just say about from negative 1 or negative 5. The maximum look like this. The maximum is not going to be much. If you're not sure about that, let's say 100, but I think 50 would be enough. And then again, the increment is 5. If you're not sure about that, put 100. It doesn't matter, but it should not be any negative number. And now let's look at the graph. Right. Look like the maximum is somewhere around here, which is 10, 20, 30, 40, 50, 60, so about 60 degrees, the maximum, right? So if we want to find a maximum, using this calculator, second, trace, and go to find maximum. In order to find maximum, we have to say where do we want the maximum. If the graph is go like this, we need to say, if we know the max is about there, we have to say that we have to indicate the interval so the calculator will know where to search. So we set the left bound. Let's say we search the maximum from there, hit enter for the left bound, move to the right of the maximum and hit enter. So the calculator will find the maximum in this interval. And hit enter one more time. It will go to this, of course, as good as 60 as so that will be 60 and about that. So the max area is about 32.476 inches square when the theta is equal to 60 degrees. Yeah, in this case we just use the calculator. If we want to get the exact number, it requires calculus, so we're not going to do that here. Alright, so more application. A surveyor can measure the width of the river by setting up a transit at the point C on one side of the river and take a side from point A to the other side A. Refer to the figures here. So let's say if we want to measure the width of the river, of course you cannot walk from this side to the river to the other side to measure the width. If we can walk across, it's easy to calculate the width, but we don't. In that case, we have to select, put C in one side of the river and the A on the other side, and we stand at B. Let's say perfect condition that it is 300 meters away, and the angle between A and C, ABC angle is 30 degrees. So we have this, and this is the width of the river that we're trying to find. Yeah, in real life it's not going to be perfect like this. In real life we have to use the triangle. That might not be a right triangle. We still be able to do that, but in here, let's say perfect condition, this is 30 degrees, and that's what we have. Right, so in that case we just need to find x. We know this side is 300 meters and the angle is 30 degrees. This is the angle. Now with respect to that angle, this is opposite, we have opposite, and with respect to that angle, this is adjacent. So we have to use the ratio that have opposite and adjacent. Well, that is tangent, right? So we say tangent of 30 degrees is equal to opposite over adjacent. That means tangent of 30 degrees, opposite is x, we don't know, but we're trying to solve it. Adjacent, we do know 300. Cross multiply, we have x equal to 300 times tangent of 30 degrees. Once again, make sure that it is in degree mode. So 300 tangent of 30. So that's 173.2, and unit of meter. Simple enough, right? Yeah, like this is a nice condition when we have the right angle here. If we don't have the right angle, then yeah, that requires more trigonometry, but we still be able to do it. But that is the way we try to measure something that we cannot walk across. Right. More application. But before we go to more application, we define the angle of elevation and the angle of depression. So vertical height can sometimes measure by the angle of elevation and the angle of depression. Okay, so if a person looking up from the horizontal line, it is from an angle that's called the angle of elevation, and if we look down from the horizontal line, that is the angle of depression. So everything with respect to the horizontal line. So with respect to the horizontal line, respect to the horizontal line, and if we look down, that is the angle of depression. If we look up, this is the angle of elevation. Oh, simple enough, right? Everything with respect to the horizontal line, right? Let's look at an example. Meteorologists try to find the height of a cloud using an instrument called whatever that is. It is a light beam goes straight to the line. Actually, that is not the device. The device is here. You will have the very bright light blow directly up into the cloud, and then we have a light detector at some distance away from it. It will detect the bright spot on the cloud, and with that they can measure the angle. And of course the measurement here from the light detector with the light source, we do know that because we both of them on a line on the ground. Assume that it is perfectly flat, so we have 90 degrees with the vertical line and the horizontal ground. Right. So at a Midway airport was employed to detect the height of a cloud. It was set up with the lie detector 300 feet away from it, and the angle of elevation is detected to be 75 degrees. So this is what we have, this scenario here. 75 degrees angle here. And we have height and then 300 feet. So with respect to that 75 degrees, we have opposite is the height, and adjacent is 300 feet. And opposite and adjacent, of course, that is tangent. So in this case, also tangent. 75 degrees. Opposite over adjacent. So we have tangent. Opposite is h over adjacent of 300. Cross multiply, so h equal to 300 tangent of 75 degrees. That gives us the height of the cloud, 300. Tangent of 75 degrees. So that is about 1,119 feet. Let's just round to the nearest feet. So that's simple enough, right? Right. So that's how we calculate the height of a cloud. Next, a more complicated example. On the top of the building, there is a statue. From the street level to observation are taken 500 feet away. Assume that we know exactly where the statue was on the ground, and we measure that exactly 500 feet away from that point. So that's kind of difficult thing to do when we look from the ground and we don't know where is at. If we extend the base of the statue down, we don't know if that is the case. But let's assume we know that 500 feet away. Right. The angle elevation from the base of the statue is 43.2, and the angle from the top of the statue is 46.1. So in this case, I will draw that there will be two triangles. So that is the ground. I will draw two triangles, one triangle. By the way, I'm not going to draw it in the exact measure like this, a little more. So let's say we have one right triangle, and one is 43.2. And then the other triangle is a bigger triangle. So that we have the height of the statue here. In that case, this angle will make up will be 46.1, but I'm not going to draw on top of that where we difficult to see. Just going to draw that here. Now this will be, say, the same width here. Yeah, but now we measure the bigger angle. 46.1. Yeah, so that's two observations. Of course, we put superimpose those two together, we have the difference. So use the ruler. Yeah, if we superimpose two on the other, we have the smaller angle, and that would be the height. Right. So we have two right triangles here, right? Assume the building is perfectly straight. Now, I'll find the height of the statue. So in that case, let this be x, right? And this will be the height. So this be h. Right. Actually, that is more confusing. It would be much better if we just said, let that be h1, and let that, the whole length, be h2, and x will be equal to h2 minus h1. Right. That will give us the height of the statue. Right. Now, with respect to this triangle here, we have h1, which is opposite, and we have adjacent of 500 feet. Here we also have opposite and 500 feet. So opposite and adjacent. Right, so to find h1, we will use tangent of 43.2 equal to opposite h1 over 500 adjacent. And cross multiply, we have h1 equal to tangent of 500 times tangent of 43.2 degrees. Yeah, just happen to be we use tangent a lot in here because we have opposite and adjacent. If the problem has to do with hypotenuse, then we bring in sine, cosine. But since we only have opposite and adjacent, we use tangent. So 500 tangent of 43.2. So that is 469. And that will be fit. That is h1. Now h2, we use the other triangle. Tangent of 46.1 equal to 500. equal to, tangent is opposite, h2 over 500. Adjacent. So h2 is equal to 500, tangent of 46.1 degrees. By the way, is that in, yeah, still in degree mode. So h2 is equal to 519.58 feet. And the height of the statue, we just take these two, subtract those two numbers. So the height of the statue is about 50 feet. Okay, so the statue is about 50 feet. Right, so that's what we have, that problem. Right, next, have another example here. The angle of depression from a balloon that is 1,010 feet above the ground to the range of the headquarters is 64.47. Find the distance of the headquarters and the point on the ground directly below the balloon. So let's say we have it's more like a hot air balloon. And the angle of depression from the balloon, look down, is 64.64 degrees 47 minutes. Right. Sorry, I have to pause the video to answer the phone. Anyway, so from horizontal distance, we look down to the angle of elevation, angle of depression, 64 degrees and 47 minutes. And the angle of depression from the balloon is 1,010 feet above the ground to the range of headquarters. So it's a headquarters here. The question is find the distance between the headquarters and the point on the ground directly below. So in that case, we ask to find x here. The distance between the headquarters and the point on the ground directly below the balloon. Alright, so we have that. And we know the balloon that is 1,010 feet above the ground. So we know this. And then just use some trigonometry. By the way, this is directly above the ground, so this will be a right triangle. So we have a right triangle here. So we ask to find x. We have the height, just need an angle, but this angle is outside of a triangle. Luckily, because this is a horizontal line and the ground assumed to be horizontal as well, so this angle is also 64 degrees and 47 minutes. Right. So in this triangle we have opposite to the angle, and here we have adjacent. So we have tangent of that angle, which is the same as 46 degree 47. (64 degrees 47 minutes) equal to opposite over adjacent. Opposite So let's do that again actually. Tangent 64, 47 equal to opposite, which is the height of the balloon, 10 over the adjacent, which we don't know, but we're trying to find it. Yeah, the angle, those two angles will be the same. So once again, cross multiply. So x tangent of 64 degrees 47 minutes equal to 10 and 10. So to solve for x, we have 10 divided by tangent of 64 degrees 47 minutes. 10. Right, it is in degree mode. Right, 10 divided by tangent of 64 degrees. So if we want to enter degree, minutes, and second, hit second apps. That gives us the angle. So second angle, 64 degrees 47. Hit that button again, minute, and then 0 second. How do we enter second? You see this is the quotation mark here. Actually that works at the second as well, right? That gives us 475.6 to the nearest foot. So 476 feet. So that will be this distance. Right. So it's easy enough, right? Now, let's say instead of ask that question, let's say this is not a hot air balloon. It's just the balloon with helium, so we'll fly up. And to keep that to the ground, we have to attach a string. Let's say if in this case we have a string to it to hold the balloon up, and the wind blow it away, so that it will form the angle of 64 degrees and 47 minutes. Let's say assume the perfect condition that the string is straight. It's not lacking. If it is lacking, that will be a different story. But assume the string is very light and it will form a straight line. The angle is 64 degrees 47 minutes still. What is the length of the string? Of course, since you found the hypotenuse, since you have this side, you find the adjacent, we can use Pythagorean theorem to find the hypotenuse here. But in this case, what I want to use is use what it is given. So if we want to find, let's say, hypotenuse, let's say we want to find R, which is the hypotenuse. So in this, let's assume that we don't know X, even though we found it. By the way, even though we found it, we prefer not to use it, because in terms of calculation, if we can use the information that is given, it will be better than the information that we calculate, because when we calculate like this, we round off to the nearest foot, so there's some error at the end. So if we want to find the accurate or the accurate hypotenuse here, we do not want to use that adjacent. So in this triangle, we have the opposite and hypotenuse along with the angle. So what ratio that have opposite and hypotenuse? Well, that is sine, right? So if we ask to find the length of the string that hold the balloon together, sine is equal to opposite over hypotenuse. Yeah, with respect to this angle, that's still opposite and hypotenuse. So in particular, we have sine of 64 degrees 47 feet for 64 degrees 47 minutes. Opposite is 10 and 10, 1010 feet. Hypotenuse we don't know. So cross multiply r sine of 64 degrees 47 minutes equal to 10 and 10. So the hypotenuse equal to 10, 10 divided by sine of 64 minutes 64 degrees 47 minutes. Right, of course I can just copy and paste and change this to a sine, but I just want to do that again. 10, 10 divided by sine 64 second angle degrees 47 second angle minutes. I think that's good enough, but I hit alpha that button. Sorry, for some reason the calculator frozen. Let me reset the calculator. Right, we have 10, 10 divided by sine 64 degrees 47 minute and 0 alpha plus second. So that much. So I need the string of the length at least 16 feet. Of course we should have more than that in reality, because there might be a lag, so the string actually have to be longer than that, but that's what we have. So let's say if we want to hold the balloon together, we need a string of that length. Right, by the way, I just want to test this real quick. What if we don't have the 0 second? Yeah, that's still the same. Right, so the reason I add this to this problem, because all of this problem up to this point we only use tangent. So I just want to use something that we use something different than tangent. In this case, we have opposite and hypotenuse, therefore we use sine, and so with that, that's what we have. Yeah. So with respect to whatever the angle is, we need to know two of them, two our opposite, adjacent, and hypotenuse, and either we know one of them, we need to look for the others. But we have to know in the problem what do we look for. So most of the problem in this section in the application, it just happened to be opposite and adjacent, so we use tangent. Here we have opposite and hypotenuse, so we use sine. If we have adjacent and hypotenuse, we use cosine. And most important, when we use the calculator, make sure that it is in degree mode. Right. So with that, I stop this section here. As always, thank you for watching, and see you in another video in calculus.